In this recording, we're going to learn how to use the normal curve, the normal model here, which we looked at in our last lesson, to make some predictions. This is just a model, and it's an imperfect model. If you remember, we had this rule 68, 95, 99.7, which says that within one standard deviation of the mean, this is our mean, the mu, right? Plus 1 to minus 1 is 68%. Plus 2 to minus 2 within two standard deviations. Remember, this is our sigma, our standard deviation. 95%. And then if you want to go out 3 standard deviations, that's pretty much everything. That's 99.7 of the data. Again, let's say what this is. This is the population mean, Greek letter that's pronounced mu. This is our population standard deviation. It's pronounced sigma. It's a lowercase sigma. Okay, those are population parameters. All right. So again, it's an imperfect model. I want to start with this little quote. Love this quote. Essentially, all models are wrong, but some are useful. And that was George Box. He was a British statistician that died in 2013. So the idea here is this is flawed. It's not perfect. Any model that we use is going to be imperfect, but it's going to allow us maybe to make some predictions if the data is bell-shaped and symmetrical and unimodal. It just has one peak here. Okay, so if you remember our dinosaur data, those compies, they pretty much resembled this shape, so we could apply the percentages of the normal model. So let's do that here. Let's do that with this example. Okay, so the average heights of women in the US is 64 inches. So right away, we can put 64 right in the middle, right? We know that 64 is the average. Standard deviation of 4 inches. Okay, well that means that when I go up 1 standard deviation, I'm adding on 4. Well, that's easy stuff. I can do that, right? 68. If I go up another standard deviation, I'm adding on another 4. I can keep doing this. We could keep doing this forever, but practically not much goes on after 3 standard deviations. It's really unusual to be out here. And we can go down by 4. Okay, so that's just how we're going to lay out before we even get into the answering of the question. In this case, there's not too much to it. It just says fill out the normal curve. I want to add a little bit more up here. I have my stat students do this. Let's add in percentiles. Okay, this is going to help us really get the normal curve. If you are average, if you are an average height woman, what is the percentile? Well, you would be 50th percentile. Okay? When you were born, your parents got information about your height and weight, and they told you the percentile that you were in. I happened to be a big baby. I was like 90th percentile in height and weight when I was a little kid. But your average person is going to be 50th percentile. Okay? And if we just kind of split this down here, and we say, okay, this whole kind of cream-colored area is 68%. Well, therefore, half of it's got to be 34%. Hopefully that makes sense to you, right? So if I add on 34, I'm at the 84th percentile. And if I take away 34, I'm at the 16th percentile. Okay, so I'm just using that 68, split it in half to get 34. 34 on this side, 34 on this side. And that means that if I'm 1 standard deviation below the mean, if I'm a height of 60, I'm like 16th percentile. That means only 16% of the women are shorter than a person that is 60 inches. Okay, so let's go a little further. 95, we're going to split that in half. So if we split 95 in half, well, let's see. That's going to be 47 and a half. Okay, so let's add on 47 and a half to 50. That's pretty easy to do. It's going to give us 97.5. Okay, and then if I take away 47 and a half from 50, that's going to give me the 2.5. It's kind of weird to say, but 2.5th percentile, 97.5th percentile, whatever. It's just to give you an idea. These are the 5 numbers that I'd always like you to put in as your percentiles. They will allow us to get a pretty accurate gauge for our prediction. Now you might say, well, shouldn't you label out here? I could. I mean, it's going to be practically 99.85 percentile, pretty much everything. And this is going to be like 0.15 percentile, but that's not really necessary for us getting a gauge right now. Okay? Now going on to Carlos. Carlos is a video game player, as are many of you. Okay? Plays average 15 hours per week. Let's underline those facts. Standard deviation of 3 hours. Okay? So what's the probability of, in a given week, him playing between 15 and 21? First, we need to make our curve. So let's start out by making a nice curve like we had above. We'll make a horizontal line. I have the advantage of a little line tool. You should probably use some sort of an edge or something. Get something you can make a horizontal line with. All right. And we're going to lay out our mean right in the middle. I'm going to label that with like 0. That's 0 standard deviations away. Okay, we said on a normal model the mean is 0. And then I'm going to mark out 1, 2, and 3. I'm going to try to make these evenly spaced. Do your best. And I don't need to go much beyond 3, remember, because that's 99.7. It's pretty much everything. Now next, I'm going to make a vertical line in several places. I'm going to make a vertical line here, sort of an arbitrary height, about that big. And that's our 50th percentile. For our 1 standard deviation above and below, these should be 60%. Like go to halfway and then go just a little more. Now if you're saying, does it have to be this way? Is it wrong if it's not? Guys, I want you to be really proud of your work. I want you to put together a normal curve that you're like, wow, that thing looks awesome. So go 60% more or less. Okay. Height key model curved. All right. Okay. Next, this one at 2 standard deviations above and below should be about a quarter of the previous one. So go to like halfway and then go half of that. Ballparking these, right? So go to halfway, but not quite that. Go to half of that. All right, so I've got my, and then this one's just like right, it's like right down. It's practically nothing, right? So then I just have to use my artistic ability, and don't tell me you don't have any. You do. Take your time. Hopefully you're using a pencil. If you're not using a pencil, this would be a good time to get one, because I just messed up a little bit and I wasn't happy with it. And I erased it, and you're just doing your best to connect to these. So it's going to come out something like that. And now let's put in the stuff we know, right? Carlos, he's an average of 15. We know where that goes, right? Right in the middle. And our standard deviation is 3. So hopefully you remember, okay, that means we're going to add on 3 each time we go up a standard deviation. So 18, 21, 24, that's easy stuff, right? Take away 3. 12, 9, 6. Cool. And now if you remember, we're going to put in our percentiles. Why don't you go ahead and cover up above. Don't peek up here at all. Cover that with something. Got a calculator, a book or something, a planner. All right, and let's see if we can put in our percentiles together using what hopefully we've memorized is the 68, 95, 99.7 rule. It's our empirical rule. Okay, so go ahead and put those in. What I'm talking about is like 50th percentile, etc. Put in those 5 numbers. Play the recording when you're ready. Okay, so hopefully you put in 50th percentile in the middle, 84th, 16th, 97.5, 2.5. If you don't remember where those came from, rewatch the previous part of the video. All right. Now let's ask the question about Carlos. 15 to 21 hours. Well, I can see those actually show up right on my distribution here. I don't have to estimate anything, I can just kind of make a shading. All right, so you've shaded in the portion. Well, I can see it's a pretty big portion, and that's why I insist on you guys making the model. We'll show you later how you can use the calculator, which is cool. It's a good way to get a precise answer, but this is a really good way to kind of check our sanity and make sure we have thoroughly thought this out and we've got an answer that seems reasonable. Okay, so I can tell that between 50th percentile and 97.5 percentile, well, that's easy to do, right? That's just 97.5 minus 50. That's a mental math right there. That's the 47.5% right there. All right, so that's using our model to get a gauge of a prediction of an answer to a probability question. Is it perfect? It's not. Is it useful? Yeah, in this case it was. Thanks for watching.